Unit 10C, Central Limit Theorem. The heights of pea plants are normally distributed with mean 20 inches and standard deviation 4 inches. If a random sample of 18 pea plants is selected, what is the probability that the mean height of the sampled plants will be between 19 and 21 inches? Well, we have a normal distribution, so we make a bell curve. And we have the mean is 20 inches, the mean of the plants. Standard deviation is 4 inches. And that would be our picture for the individual plants. But we're not dealing with individual plants. We're going to have a random sample. We want a sample of 18 plants, and we're looking for the mean of the sample. And when you're looking for a mean of a sample, we're going to have to use the central limit theorem, because we're not going to be talking about individual scores, x's, but rather sample means, x bars. So by the central limit theorem, we know that the x bars will be normally distributed if the sample size is 30 or more, which is not, it's only 18 here, or if the heights of the individual plants are normally distributed, which they are. So therefore, the x bars are going to be normally distributed. We're going to make a curve for the distribution of the x bars. They're going to be normally distributed. I'm going to make another normal curve. If I wanted to be precise about this, I would have to say this normal curve should be have smaller standard deviation, so it should be more squashed together like this. But anyway, by the central limit theorem, mu of the x bars is going to be the same as mu for the individual scores, namely 20, and the sigma of the x bars, however, will not be the same as sigma of the individual scores. It will be sigma divided by the square root of n, which is sigma is 4, divided by the square root of the sample size, 18. And if you do that on the calculator, you're going to get approximately, rounded off to 2 decimal places, 0.94. And what do we want? We want the probability, which for us means area, between 19 and 21. So 19 will be someplace over here, and 21 over there. So we're looking for this area. The problem could be done on the TI-84 with the built-in function NormalCDF. We're looking for this area. What you need for the NormalCDF is the low end of this interval, the high end of the interval, mu and sigma. So it's second distribution, number 2, NormalCDF. You put in the low end, 19, the high end, 21, mu is 20, and the standard deviation is 94. Navigate to paste, press enter, and there's the answer. Approximately 0.71 or 71%. It's a little more difficult to do this sort of problem by hand, what we want to find is this area. We know we're going to use a table. The table only compares areas with z-scores, so we're going to have to get z-scores first. So for this 21, to change that to a z-score, that's x minus mu over sigma. 21 minus mu is 20 over the standard deviation now is 0.94. So 1 over 0.94, that's going to be 1.0638, etc. Our table carries 2 decimal places for z-scores, so we'll round off to 2 decimal places, 1.06. Similarly, for 19, to change 19 to a z-score, z equals 19 minus mu over sigma, and you'll see that that's going to come out to negative 1.06. That should make some kind of sense because of the symmetry of the curve. 21 is 1 inch above the mean and 19 is 1 inch below the mean, so their z-scores should be opposites of each other. Well, now we have the z-scores. How do we get the areas? Well, the first step would be to look up 1.06 in the table. If you do that, you're going to get an area of 0.8554. That means this area below is 0.8554. Then we look up negative 1.06 and we'll get this area below that, score of negative 1.06, and that's 0.1446. Well, the red area is too much. The blue tail has to be subtracted from the red area to get our answer. So it would be 0.85554 minus 0.1446. If we subtract those, we should get 0.7108, which is again about 71%. The answer is a little different from what we got on the calculator because we're using rounded off z-scores to 2 decimal places. The calculator is going to carry more decimal places. Our table only has 4 decimal places for areas, and the calculator may carry more places than that. So therefore, the calculator answer is a little better than our answer would be. We could check our answer using the empirical rule. If we go 1 standard deviation from the mean, standard deviation is 0.94. If we add 0.94 to 20, we get 20.94. And if we go 1 standard deviation the other way, subtract 0.94 from 20, we get 19.06. Well, we've memorized these areas, so therefore this area is going to be a total of 34 and 34, or 68%. Well, we were finding areas between 19 and 21. Now 19 would be about here. That's 19. 21 is a little bit above this one. 21. So does it make sense that the area from 19 to 21 would in fact be a little bigger than 68%. So this blue area is a little bit bigger than 68%. So a little bit bigger than 68%. 71% sounds reasonable by the empirical rule. So in summary, the probability that the mean height of the sample pea plants will be between 19 and 21 inches is 0.7108, or about 71%. This is the end of Unit 10C.